In today's demonstration, we're going to be performing configurations to set up microsegmentation using the RUCKUS WAN gateway. You'll typically see microsegmentation deployed in MSP and HSP environments where you want to have users that have their own layer 2 and layer 3 connectivity. So we're going to be creating some layer 3 networks and associating those with layer 2 VLANs. As a quick review of the environment, we've got a virtual RUCKUS WAN gateway configured with two interfaces. One of them is connected to the internet. The other is connected to an ICX switch, which has a virtual smart zone attached to it, as well as a RUCKUS access point. So this access point is going to be broadcasting a network that we are going to configure for microsegmentation. Now, all of the configurations on the RUCKUS WAN gateway to adopt the virtual smart zone as well as the ICX have already been performed, and there are videos on how to do that, so refer to those if you need them. What I think is really cool is that now that we're at this point, all of the configurations that I'm going to perform to implement microsegmentation, we're going to do from the RUCKUS WAN gateway. Before we start doing that configuration, however, we do want to verify that the smart zone and the ICX are operational and imported successfully. So head over to Network, Wireless, and you can see we do have our WLAN controller defined. It's online. It's in configuration synchronization. We do have the access point there, the T310D. It is in the zone site A, as we can verify as well. So that is all operational. Heading over to Network Wired, we can see that our ICX is also online and it is in a positive config synchronization status. So before we get started with all the configurations, we just want to check those two things, and we will go back into the smart zone and into the ICX just to kind of verify that the changes that we are making are synchronizing properly. Getting started with the configuration, we're going to go over to Network and LAN. The first thing that we're going to define are the VLAN interfaces that we want to use for microsegmentation. I'm going to go ahead and click Create New as I have none defined, and we're going to begin by giving it a name, Microsegmentation VLANs. We're then going to select the physical interface that's connected to our downstream ICX, which is VMX1. We're then going to set our starting VLAN ID of 100. This is the first VLAN that will be used in our microsegmentation demonstration. Auto increment is set to per subnet by default. This means that every subnet that I define is going to be getting an additional VLAN ID. I could change this. I could set it to none, which means that we would just be creating this one particular VLAN, or I could set it to per IP, meaning that each IP address would get its own VLAN. But in this case, we're going to do per subnet, and we're going to do it at a ratio of 1. This means that the next subnet would be VLAN 101, and then the one after that, 102, etc. With all that defined, I'm going to go ahead and click Create. The next thing that we need to do is define our network addresses for microsegmentation, and I'm going to go ahead and click Create New to do that as well. First, we name them. I'm going to choose microsegmentation addresses, and then I'm going to actually disconnect the association to the Ethernet interface, and I'm going to attach the associated microsegmentation VLANs that we just created. The next thing that I need to do is define the starting IP address for this block of addresses that we're going to use for microsegmentation. In this case, I'm going to choose 10.10.100.1/30. What this means is that every microsegmentation network that I create is a /30 with 2 usable host addresses. I'm then going to set my auto increment. By default, it is set to 1, meaning that if I just clicked create here, it would create just this one network, but I want more than one network. We've got several users that we want to be able to use this. In this case, I'm just going to set it to something rather small, 32. So we'll get 32 networks that are built off of this. So what that means is, since we've attached it to our microsegmentation VLANs, which start at VLAN 100, really if we filled this all the way up, we should see VLANs 100 through 131 created. The last thing that we want to make sure that we do is create a DHCP pool for each of these subnets. This is going to make it so that everybody that's connecting in is able to pull a IP address from their individual network. This makes it super easy so that you don't have to go and create all of these pools manually. So with that checked, I'm going to go ahead and click Create. Now let's verify these configurations. Let's hit refresh under VLAN interfaces. And we can see it does populate now that we have VLANs 100 through 131. We can also see our microsegmentation address block at 10.10.100.1/30 to 10.10.100.125/30. So we've got 32 usable subnets. If we SSH into the RWG device, we can run ifconfig and take a look at all of the created VLANs and see the associated network addresses that are used. We can also validate our DHCP pools. If we go over to Services DHCP, we should be able to see our microsegmentation pool listed here. And if we go back into the SSH session of our RWG device, we can take a look at the DHCP config file. We can see all the DHCP pools that were created based on the configurations that we applied. Now we need to configure our network address translation. We're going to go over to Network NAT, and we are going to define a NAT. So we're going to click Create New. We're going to start by defining the name as NAT microsegment. We're going to select our uplink here. This is the uplink that we're going to use for this particular NAT translation. And then we have to define which addresses we're NATing. So under the subnets addresses field, we're going to select our microsegmentation addresses, and then we're going to go ahead and click Create. So we've created VLANs, we've created some network addresses, and we've set up the network address translation. But those VLANs don't yet exist on our ICX switch. We're going to go over to Network Wired, and we're going to create a switch port profile for those microsegmentation VLANs. So under switch port profiles, I'm going to go ahead and click Create New. I'm going to go ahead and name the profile microsegmented VLANs. I'm then going to select which ports that this profile will apply to. I'm going to go ahead and choose port 2, which is connected to my AP, and port 12, which is my uplink back to my RWG device. I then need to define what VLANs I need to have. And as you will recall, we created the microsegmentations VLAN bundle starting at VLAN 100, and I want to make those tagged. So I'm going to go ahead and from the tagged VLANs field, choose microsegmentation VLANs. All the other settings here are as we need them, so I'm going to go ahead and choose Create. So you can see that my microsegmented VLANs port profile is there, and it is attached to ports 12 and 2 on the switch that I have defined and managed by RWG. Let's go ahead and take a look at that ICX just to verify the configuration. We can run show VLAN from the device and see VLAN 1 as well as the VLANs that we created. VLANs 100, 101, 2, 3, 4, all the way down to 131. And of course, we still have port VLAN 999, which is part of the authentication VLAN that is created when you onboard an ICX into RWG. So at this point, all of the VLANs on the ICX were defined and they were tagged on the proper ports, and all we had to do is create that in RWG. The next thing that we want to do is validate our radius configurations, and a lot of these were actually defined when we imported the Smart Zone into RWG to get the management going. We're going to go over to Smart Zone and look at our security realm-based proxy and just verify that we have an entry that points to our interface on the RWG. We can see 10.10.10.1 here, and if we configure it, we can see that it has the no match and unspecified map as well as the radius policy map. We expect all of this to be configured automatically, and we just wanted to verify it is here. We can then go over to our proxy SC authenticator and again verify that we have an entry pointing into our RWG instance. And we can see that here again as 10.10.10.1 radius policy, and we can configure it. This does have the IP address towards the RWG device as well as the port and shared secret information. If you needed to update your shared secret, we can do so here, but it is actually defined within the RWG instance. I'm going to go ahead and click cancel. We're going to flip back over to RWG and look at services radius and take a look at the radius server options. So you can see we have a default here with a secret of _DQTAJ. If we edit that, this is what's actually defined as our secret on our device. So if we wanted to update the shared secret between radius and Smart Zone, we would do that here and then go apply that to the Smart Zone server. But this is auto-generated, so we should be okay to leave it as is. The next thing that we need to do is actually create a radius realm. As you can see, we don't have any defined, so we're going to go ahead and click Create New. A radius realm is important because it's how we're going to determine what's going to happen when a user logs into the WLAN. In our case, what we want to have happen is we want them to be associated to one of those microsegment networks. So this is how we make that work. We're going to go ahead and name this microsegmentation realm, and then we're going to set the realm admission logic to policy or attribute. This is what it is by default. We then need to make sure we are doing the default policy only, and then we need to set up an attribute pattern. For the attribute priority, we're going to select 0. For the logic, we're going to choose OR. For the attribute, we're going to actually set it to be off the BSSID or the SSID, and then this is where we need to define what the WLAN SSID would be. In this case, I'm just going to set this to micro. Under sharing, we're going to change this from per account to per device, and then we're going to go and select our VLANs for microsegmentation. Under infrastructure devices, we can see our 2 infrastructure devices listed here. We want to make sure that we're choosing our smart zone instance. And then under behavior, we want to make sure that we are utilizing the type VLAN, the tunnel IEEE 802, as well as the private group ID, but we're going to actually uncheck the tunnel password. So we only need these first 3 options to get this working. And then with all that defined, we're going to go ahead and click create. The last thing that we need to do is create the WLAN. And again, we're going to do that from RWG. Let's go over to network wireless and click create new under the WLAN scaffold. I'm going to go ahead and call this microsegmentation WLAN. From the access point zone, I need to select that site A zone. That's where this AP that we've created for our topology lives. It is on the Smart Zone 51 controller, and we do want to associate it to the default profile on that zone. The next thing that we need to do is specify the SSID. And as you'll recall in that radius realm, we named it micro. So I want to make sure we can match that. And I'm naming this micro as well. The authentication is going to be MAC bypass. We are going to be utilizing 2.4 and 5 gigahertz for this particular WLAN. We also need to make sure that local radius server is selected and that our microsegmentation VLANs are checked here. With all of that defined, we are ready to click create. We can now see that we've got a microsegmentation WLAN in site A with an SSID of micro. If we go over to the smart zone and we go to network wireless LANs, we can see the microsegmentation WLAN configured with an SSID of micro. And if we jump into that, we can see that it has a standard auth type with an auth method of MAC address. It is not using any encryption, but it is using this 10-10-10-1 radius policy. So with that, I think we're ready to test and make sure that we can join this WLAN. I've already connected to the micro network from my mobile phone, but I wanted to show the process from connecting using this laptop. If I go under my wireless availability, I can see the micro network here, which again, we set as an open network. So all we should have to do is click connect. And once it's connected successfully, we can run an IP config all, and we can see which network this is actually connected to. So we can see that this particular adapter is pulled 10.10.100.14. Back in RWG, if we look under Instruments, Mac DHCP DNS, we can see the 2 clients that we've connected. You can see them on VLAN 103 and 104, and this is because I actually connected some devices other than these 2 to test those connections, but we've got the phone and the laptop connected. Again, we said the laptop was at 10.10.100.14, and the phone is at 10.10.100.18. I can bring over the laptop's configuration and we can try to ping 10.10.100.18, and it should not be able to ping. That is because we have the default block subnet rule that prevents communication between subnets, but this device can reach the internet. So that kind of concludes the demonstration that we had planned today. It shows how easy it is to use RWG to define these microsegmented networks, all from this interface. We created the networks, the VLANs, we did the switch configuration, the radius configuration, the WLAN configuration, all from right here. Hopefully you can utilize what we've shown here in your environments, and we look forward to you joining us for the next one.